Hello guys, today we're going to be solving October number 2023 0620 paper 21. So let's start. Question 1. A gas is placed in a sealed container. Gas has pressure of 1 atmosphere and a temperature of 50. It is heated to 100. Which row describes the cause of pressure and the effect of increasing the temperature on the gas? So the gas pressure is caused when the gas particles collide with the walls of the container. It is not when the gas particles collide with each other. It is when gas particles collide with the walls of the container. So it's kind of between C and D. And when you increase the temperature, collisions become, so in C they say the collisions become less frequent. No, they're gaining energy, so they will collide more. The D is then the average speed of the gas particles increases. So yes, that is correct. So B is, so question number 1 is D. Moving on to question 2. For experiments each containing a different acetic gas are set up as shown. The dividing glass plates are removed at the same time. In which set of apparatus does the litmus turn red first? So we have acetic gases in the bottom part of the container, like we have in A we have carbon dioxide and HCl, and then nitrogen dioxide and sulfur dioxide. They are asking in which apparatus does litmus turn red first. So the gas which is going to travel the fastest will turn the litmus paper red first, and the gas which is going to travel the fastest is going to be the one who has the least molecular mass among all these four. So if we calculate the mass, for carbon dioxide it's 44, for HCl it's 36.5, for NO2 so it is 46, and for sulfur dioxide, sulfur is 32 and then plus 32, this is 64. So we can see that the least molecular mass is of HCl, so it is going to be B, because the least molecular mass will travel the fastest. Question 3. Group 1 element potassium forms an ionic bond with group 7 element fluorine. Which two ions are produced? So potassium, which is in group 1, it is going to lose one electron, so it's going to have K positive, so we can rule out C and D. Group 7 element fluorine, it is going to have a charge of -1, so we will have B. B is the answer. K plus and F minus. Question 4. X and Y are atoms. X and Y have the same number of electron shells. They have the same number of outer electrons. They have different mass numbers. Which statements about X and Y are correct? So whatever these statements they've given, what can we infer from them? They've said that they have the same number of electron shells. It means that they belong to the same period. Then they have the same number of outer electrons, means they belong to the same group. And they say that they have different mass numbers. So let's look at these statements. What are correct? They are isotopes? Yes, they are, because they're the same atom. How we got to know that? From the first, like same period and same group. Then they have the same total number of electrons. Yes. They have the same chemical properties. Yes, because isotopes have the same chemical properties. So it's A. Question 5. Lithium chloride is an ionic compound and silicon peroxide is a covalent compound. Which statement about both compounds is correct? So they're asking about both of them. They have given ionic compound and a covalent compound. So they're asking which statement is correct for both of them. They are not soluble in water. Lithium chloride is soluble, so this would be wrong. They conduct electricity when melted. Covalent compound is still not gonna conduct electricity. They do not conduct electricity in solid form. This is correct because ionic compound either has to be in aqueous form or molten form to conduct electricity, and covalent compounds not going to conduct electricity in any form. And they have low melting points? No, they have very high melting points. So C is correct. Question 6. Which equations are balanced? So now we just have to look like which equations are balanced. So let's see. We have 2 iron over here, we have 2 iron over here. And then on the left side we have a total of 6 oxygen. And on the right hand side also we have 6 oxygen. We have 3 carbon and we have 3 carbon. Yes, so this is balanced. Now we have 1 zinc, and we have 1 carbon and 1 carbon. Then we have 3 oxygen. Over here we have 4 oxygen because 2 oxygen here and then 2 oxygen here. So this is not balanced. And then we can also see that we have 2 hydrogen on the reactant side but then 4 hydrogen on the product side. So this is not balanced. Now we have 1 magnesium, 1 magnesium. Then we have 2 nitrogen because it's 2. And we have 2 nitrogen here also. And then we have 6 oxygen and 7 oxygen. Over here we have 2 oxygen and 6 oxygen. So we basically have 8 oxygen over here, but over here we just have 7 oxygen. So this is also incorrect. Now fourth, 1 calcium, 1 calcium, 1 carbon, 1 carbon. We will count the number of oxygen atoms at the last. So there's 1 sulfur, 1 sulfur. There are 2 hydrogen, 2 hydrogen. And then oxygen on the reactant side are 3 plus 4, 7 oxygen. So we have 4 oxygen, 5 oxygen and 7 oxygen. So this is correct. So 1 and 4 only are balanced, so it's B. Which row shows the formula of sodium carbonate, zinc nitrate and ammonium sulfate? So sodium carbonate, sodium has +1 and carbonate has 2 minus. So when it crisscross we have Na2CO3. So it's among A and B, right? For zinc nitrate we have zinc 2 plus and nitrate has a charge of -1. So we have zinc NO3 whole twice. So till now we have B, and then let's also check for ammonium sulfate. Ammonium has a charge of this and sulfate has a charge of this. So it becomes this when we crisscross the charge. So it's B. 7 is B. Question 8. Which statements about hydrogen and oxygen are correct? Hydrogen and oxygen can react to produce electrical energy. Well, yes, they can react to produce electrical energy because in hydrogen fuel cells, they react and then they produce energy. So this equation is correct. So it's going to be between C and D. Hydrogen and oxygen can be made by the electrolysis of dilute aqueous sodium chloride. So let's see, when we have dilute aqueous sodium chloride, so we have sodium chloride and then we also have water. So basically have Na plus and H plus, then we have Cl minus and OH minus. Now these Na plus and H plus, they're gonna go to the cathode, which is the negative one. Chloride and hydroxide, they will compete to go at the anode, which is the positive one. Now with the cathode, the less reactive metal is going to go, like the less reactive element. So over here, less reactive is hydrogen. So hydrogen will produce, yes, it will produce at cathode. At anode, OH minus is going to go because OH minus is less reactive than, so OH negative is less reactive than chloride. So that's why this is going to go at the anode. And when OH minus goes at the anode, it produces oxygen gas. So the answer is D, that yes, hydrogen and oxygen both will be produced. Question 9. Graphite has a giant covalent structure. Which statements Which statements about graphite are correct? Carbon atoms form four covalent bonds with neighboring atoms. This is wrong. This actually happens in diamond. In diamond, all the four bonds of carbon are bonded to other carbons. In graphite, actually, there is like each carbon bonds to three other carbon atoms. One bond is free. So this is wrong. There are delocalized electrons between layers of carbon atoms. Yes, there are delocalized electrons because graphite conducts electricity, and if it conducts electricity, it means that there are delocalized electrons. Graphite is a useful lubricant. Yes, it is. Graphite is a good conductor of electricity. Yes, it is. So 2, 3, and 4, it's C. Question 10. Which reaction pathway diagram represents an endothermic reaction? So remember, in endothermic reaction, energy is taken in. Energy is taken in. So basically, energy is going to increase. Like the product, they're going to be at a higher energy level. So C and D can be ruled out. Products have to be at a higher energy level because energy is taken in. Now in A, they've said that it's negative 24. In B, they've said it's plus 24. When it's exothermic, the sign is negative. When it's endothermic, the sign is positive. So the answer is B. Question 11. Hydrogen burns in oxygen. Equation is shown. The table shows bond energies. What is the energy given out during the reaction? So energy given out means it's exo, which automatically means that the sign is going to be negative, and all of the options are in negative. Okay. So let's see. I'm going to draw the displayed structure. So H2 is like this, but then 2 times. O2 is this, and then H2O is this, but then there are 2 molecules. So we know that del H is H1 minus H2. Let's separately find H1. H1 is going to be 2 into the HH bond, so 436 into 2 plus O double bond O, 498. 436 into 2 plus 498. So it's 1370. And then H2 is going to be, so the value of OH is 464. In one molecule of water, there are 2 OH. So this is one OH, this is the second OH, and then there are 2 molecules of water. So in total, there are going to be 4 OH. Like this is another water molecule. So there is 1, 2, 3, 4. So basically 4 OH. So it's going to be 4 into 464. 1856. So del H is going to be 1370 minus 1856. Negative 486. Negative 486 is C. Now, which process involves a chemical change? Remember, it's a chemical change when there is a reaction happening. And like some bonds are being broken and new bonds are being formed. That's a chemical change. If it's simply a state change or something like that, if it's simply a state change or something is dissolving or something like that, it's just physical change. So let's see. Question 12. So adding sodium to water. Okay, when we add sodium to water, remember group 1 metals are very explosive. So sodium reacts explosively with water. So sodium does react with water, and it is a reaction, so it is a chemical change. It is. Let's see others. Boiling water. No, it's just a state change, as I said, so it's physical change. C. Dissolving sodium chloride in water. Again, just it's like the crystals of sodium chloride, they're going to dissolve in water. So there is no reaction that is happening. Dissolving, no reactions. And then producing water from aqueous sodium chloride. No. A. 13. An experiment is carried out to find the rate of reaction between hydrochloric acid and zinc. This is the equation. The results of the experiment are shown. Okay, so it's y-axis versus time. And what is the label on the y-axis? Right. Amount of zinc chloride produced. No, this cannot be, because we know that as the reaction proceeds, the amount of product should be more. So like for A, the graph should have been something like this. Like it would have increased as the reaction would be proceeding. Then B, concentration of HCl. Okay, this can be. Let's see. Mass of zinc reacted. Okay. And the volume of H2 produced, no, it will be the same graph as of zinc chloride. Now between B and C, if we look at option number C, they say that mass of zinc reacted. So as the reaction is going to proceed, the mass of zinc that's going to react, it is actually going to increase. Like there was one graph that mass versus time. When it was simply mass, so the graph was like this. Like the mass was decreasing as the reaction was proceeding. This was mass of a reactant. Mass of a reactant decreases as the reaction proceeds. They are saying that mass of zinc reacted. Mass of zinc that is reacted. So as the reaction is going to proceed, the mass of zinc that is going to react will actually increase. Right? Like more and more mass of zinc will react as the time proceeds. So mass of zinc that has reacted will actually increase with time. It's not lost in mass or something. They're saying mass of zinc that is reacted. So mass of zinc that is going to react will actually increase as the reaction proceeds. So this is wrong. So B is the option. That concentration of HCl, yeah, that HCl will decrease with time. 14. Hydrogen peroxide H2O2 decomposes to form water and oxygen. Manganese peroxide catalyzes the decomposition reaction. The reaction is investigated in 4 experiments. So these all are the 4 experiments. All reactions go to completion and all measurements of gas volumes are at room temperature and pressure. So which statement is correct? Now in the experiment, they gave us volume and concentration of hydrogen peroxide. So it was the volume and concentration, and then they told us some conditions like 25-degree manganese peroxide powder added and all. Now from volume and concentration, what can we actually find? Give us the volume and concentration of hydrogen peroxide. We know a formula that goes like N is equals to Cv. So from all of these data, from the concentration and volume data, we can find moles of H2O2. When we find the moles of H2O2, we can find the volume of gas that is released. 1 into 12.5 upon 1000. So in this we have in experiment number 1, we have 0.0125 moles. Then in experiment number 2, in experiment 2 the moles are 0.025. In experiment 3 the moles are 0.025. In experiment 4 the moles are same, 0.025. So, and now we have to find the volume of oxygen that is produced. We can see from the equation the mole ratio of H2O2 and oxygen, it is basically 2:1. So basically like 2 moles of H2O2 give us 1 mole of oxygen. I'm gonna write here. In the first experiment, the moles of H2O2 were 0.0125. So the moles of oxygen are gonna be divided by 2. Like if we do the unitary method, we have H2O2 ratio oxygen. If 2 moles of H2O2 give us 1 mole of oxygen, so 0.0125 moles are going to give us X. So basically 0.0125 will be divided by 2. So it's going to be 0.00625 moles. Now to find the volume, we will use this formula: mole is equals to volume upon 24 dm cube. So the moles are 0.00625 into 24 will give us the volume into 24. So the volume of oxygen is 0.15 dm cube. And then we'll repeat the same steps for the other experiments also and find the volume of oxygen in other experiments. So in experiment 2, 0.025 moles of H2O2. So for oxygen, it is going to be divided by 2 and it will be 0.075. Now the volume of oxygen would be 0.075 into 24, just like the previous steps. And it's 1.8 dm cube. Right. And then in experiment 3 also, when the moles were same, so everything will be same, 1.8 dm cube of oxygen. Even in experiment 4, 1.8 dm cube of oxygen. So now let's see the options. Experiment 1 produces less gas than experiment 4 but at the same rate. So in 1 we have 0.15 dm cube and in 4 we have 1.8. So yes, it's less. So 1 does produce less gas than 4 but at the same rate, they're saying. So in 1 it's 25 degree with manganese powder and in 4 it's 40 degree with manganese powder. So when the temperature is more, the rate cannot be the same. A is wrong. In B, 2 produces more gas than 1 but at the same rate. So 2 does produce, like in experiment 2 we have 1.8 and 1 we have 0.15. So 2 does produce more gas than 1 but at the same rate, they're saying no. Again, it's the same difference, 25 degrees and 40 degrees. So no. C. 2 and 4 each produce the same volume of gas but at different rates. So yes, in 2 it was 1.8 and 4 it's 1.8 but at different rates, they're saying. So in 2, 40 degrees with manganese oxide powder, and in 4 the rate will also depend, like it's not just the temperature but it's also the concentration. Volume doesn't matter that much but concentration does. So they're saying 2 and 4 produce same volume of gas but at different rates. So 2 and 4, the do produce 1.8 dm cube of gas but at different rates. So 2 is 40 and 4 is also 40. Let's look at the concentration. In 2 it's 2 mole per dm cube and in 4 it's 1 mole per dm cube. So concentration of H2O2 is also halved. So that's why the rate will be different. Over here the rate will be affected by temperature and by concentration of the reactant as well. So C is correct. 3 and 4, same volume of gas are produced, yes, and at the same rate. 3 and 4, the temperature is same. 3, they're saying 40 degrees without manganese powder, 40 degrees with manganese powder. So when manganese is not going to be there, the rate will not be the same. That's wrong. So 14 is C. sulfuric acid produced by contact process, which row shows typical conditions used in the process. So the catalyst is vanadium 5 oxide between C or D. Now we know that the temperature is the temperature is 450. It's not 300. And if we talk about the pressure is 2 atm, and we know that 1 atm is 1.0 into 10 raised to power 5 pascals. So 2 atm would be 2.0 into 10 to the power 5, basically 200,000. 200,000 pascals, yes. C. Reduction of copper. So reduction of copper means that oxidation state of copper would decrease. So let's assign in A we have copper 2 plus, oxygen 2 minus, carbon is 0. Over here we can say that carbon has become 0 and this is minus 2, so carbon over here has become plus 2. So oxygen over here has gone from plus 2 to 0, so that is reduction. That's A. Check the others. Over here in COD nothing is there, just the state is changing. In B, sulfide is 2 minus, so copper is 2 plus. And over here it's 2 minus and 2 plus. In B it did change the oxidation state of copper. So for 16 it's A. 17. Which statement about acids is correct? A weak acid partially dissociates in aqueous solution? Yes, it does. A is correct. Acid accepts protons. No, that's base that accepts protons. Ethanoic acid acts as strong acid when added to water? No, it's a weak acid. Hydrochloric acid is a strong acid that ionizes in water to form H minus ions. It's not H minus, it's H plus. So it's A. Copper sulfate is formed by reacting excess solid copper to carbonate with dilute H2S with sulfuric acid. Which processes are part of the preparation of copper to sulfate? So copper to sulfate is a soluble salt. We know that we prepare it and then we filter it and then we crystallize it and then we filter it again. So it includes crystallization, it doesn't include distillation, it includes filtration, no titration. So it's 1 and 3, it's A. 19. Which type of reaction is represented by the equation shown? So it's addition, redox, neutralization, precipitation. Over here we can see that they have given us the equation in ion. Like, so if we do one thing, like if we just cancel the same ions that are present on either side, like it's nitrate and then it's nitrate, it's Na plus, it's Na plus. So I've just cancelled the same ions on either side. Then we are left with this equation, lead 2 plus aqueous plus 2I minus aqueous, and it gives us lead iodide solid. This ionic equation is basically for a precipitation reaction in which there are like ions in aqueous form and they form a solid compound which is insoluble in water. So this ionic equation is for precipitation. Which 20, which compound is likely to be colored? It's A, because usually only transition elements they are colored. So in A there's a transition element manganese, there's no transition element in B, C or D. 21. Which statements about the metal zinc are correct? So it's extracted from the ore bauxite. That is wrong because bauxite is for aluminum. 2. It is used to galvanize steel. Yes, zinc is used because zinc is more reactive, so it is used. It is used to make the alloy brass. Yes, zinc is used in making brass. Then it reacts with dilute hydrochloric acid to produce hydrogen gas. Yes, zinc when reacts with hydrochloric acid, it gives zinc chloride plus hydrogen. So So this is correct. So 2, 3, and 4, it's C. The electronic configurations of 4 elements P, Q, R, S, and G are shown, which elements are unreactive monoatomic gases. So electronic configuration is just 2. This is helium. 2 and 2, like the basically 4 electrons are there. So the one which has 4 electrons is beryllium. Are present in beryllium. Then 2 and 6, 8 electrons are present in oxygen. 2 and 8, 10 electrons are present in neon. So unreactive monatomic gases are helium and neon. So it's P and S, it's B. 23. Which one compares the strength of alloys with pure metals and explains the difference in strength? So we know that alloys are stronger than pure metals, so it's not A or B. Then what is the explanation? So for part C, they say that larger atoms slide more easily over smaller atoms. Well, larger atoms actually make it harder because they are big in size. So D states that larger atoms make it harder for layers to slide over one another. So yes, it's D. Zinc oxide reacts with carbon to produce zinc. Which equation represents this reaction? So this is basically a reduction like a reduction process. Carbon is a reducing agent. So basically over here we are seeing the balancing. Here's all our zinc oxide, then carbon, and then all our zinc, and then this and this. So we're basically looking at the balancing of the equation. So 2 zinc with 2 zinc, 2 oxygen with 1 oxygen, so that's wrong. Now 2 zinc with 2 zinc, and then 2 oxygen with 4 oxygen over here, so that's wrong. 1 zinc with 1 zinc, 1 oxygen with 1 oxygen, 1 carbon with carbon. This is balanced. What about D? 1 zinc with 1 zinc, then 1 oxygen, and over here we have 4 oxygen. That's wrong. So for 24, it is C. When a piece of aluminum foil is added to dilute hydrochloric acid, no effervescence is seen. Which statement explains why no effervescence is seen? Aluminum is basically a very reactive metal and it reacts with the air surrounding it. So basically, there is an oxide layer that forms over aluminum. So that is what makes it unreactive. So aluminum does not make a gas when it reacts with an acid. No. Aluminum has a surface of aluminum oxide. Yes. Less reactive than hydrogen, it is more reactive. Only reacts with concentrated acid? No. So B is correct. Now our nails are stored in an airtight container. The nails begin to rust after a few days. How can the rusting of the nails be prevented? So we know that for rusting there are two things. It's water and it's air. So if we can get rid of water and air, we will get rid of rusting. So in part A, they're saying leave the lid off. No. When you leave the lid off, air is going to react. Replace the air with argon. Yeah, we can do that. Because argon is an unreactive gas. And we won't have any air also. Put the container in a warm place. Temperature won't do anything. Seal the container in a bag. It will make no difference. So it's B. 27. Four substances present in the blast furnace during iron extraction are listed. Which substances are both a reactant and a product during the reactions occurring in the blast furnace? So calcium carbonate. Calcium carbonate is just a reactant which reacts with the Calcium carbonate is just a reactant, it is not a product. Carbon dioxide, yes, it is produced as a gas, and it also uh, it also reacts with the compounds like for reduction stuff. So yes, it is. Carbon monoxide, yes, carbon monoxide is formed by incomplete combustion and is also used as a reducing agent. Iron 3 oxide, it is just the product, it is not a reactant because that is what we are producing. So it's just 2 and 3. Let's see. Aluminium is 28. Aluminium is extracted from purified bauxite by electrolysis. Shows the half ionic equations for reaction at each electrode. So anode is basically the positive one, the cathode is the negative one. So the positive electrode we would have negative ions, so it's between C and D. Now at anode we have oxidation and at cathode we have reduction. So at anode we have oxidation and oxidation means loss of electrons. At cathode we have reduction means gain of electrons. So 28 is D. 29. Which test is used to show that a sample of water is pure? A. Evaporate the water to see if any solids remain. We have evaporated the water. How can we check if it's pure? It's wrong. Heat the water to check its boiling point. Yes, checking the boiling point and melting point of substances is actually a test for purification. Test with anhydrous cobalt 2 chloride. Cobalt 2 anhydrous doesn't contain any water. How will we test it? Use universal indicator paper to check its pH. The method in D, it's not as accurate as B. Like even water, like in pH, there are like a range of values. It's not consistent. It's not constant. So B is the most appropriate method. 30. Catalytic converters in car exhaust change polluting gases into non-polluting. Which statements about oxides of nitrogen in car engines are correct? Oxides of nitrogen in car engines. Now, the nitrogen in oxides of nitrogen comes from compounds in gasoline. That is wrong. Both oxygen and nitrogen come from air and they react in the engine at high temperatures. Now, the oxygen in oxides of nitrogen comes from the air in the car engine. Yes. Catalytic converters convert oxides of nitrogen into nitrogen. Yes. So it's 2 and 3. It's B. 31. The structures of two molecules X and Y are shown. Which one describes X and Y? So first is like, are the structural isomers and do they belong to same homologous series? Structural isomers are those isomers which have the same molecular formula but different structural formula. Okay, we can see that X and Y have different structures, but do they have the same molecular formula? So we can calculate the molecular formula or simply just first look at the number of carbon atoms. In X there are 1, 2, 3, 4, 5, 6, 7. We have 7 carbons, and in Y we have 1, 2, 3, 4, 5, 6. We have 6 carbons. When the number of carbon atoms are not same, so the molecular mass automatically is not going to be same. So molecular mass is not same, so they are not structural isomers. It's between A and B. Belong to same homologous series? Yes, they do, because there is a double bond between carbon and carbon. So it's alkene. So it's B. 32. What is the structure of butanoic acid? Okay, so butanoic acid. Butane means there are 4 carbons, and acid has this moiety attached to it, C double bond O, OH, and all of these are H. So this matches with D. There are 4 carbon atoms, 1, 2, 3, 4, and we have this moiety. 33. When a mixture of methane and chlorine is exposed to ultraviolet light, a reaction takes place. which statements about this reaction are correct? So it's an addition reaction, it is not. It is actually a free radical substitution reaction. When methane is reacted with chlorine in the presence of ultraviolet light, it is not an addition reaction, it is simply a substitution reaction. So, 2. The ultraviolet light provides the activation energy. Yes, it does provides the activation energy. 3. An equation for the reaction is this. This is not actually any equation in the reaction because firstly only like one chlorine gets attached to methane one at a time, and always HCl is produced. Hydrogen is never produced. Therefore, H3Cl is made in the reaction. Yes, it is. When like we get CH4 with chlorine, we get CH3Cl plus HCl. So it is produced. So it's 2 and 4. It is D. 34. Esters are formed when carboxylic acid reacts with alcohol. What is the catalyst for this reaction? So when esters are formed from carboxylic acid and alcohols, the catalyst is basically H2SO4 sulfuric acid. This is basically an oxidizing agent. No, iron is used in the Haber process, sulfuric acid. Vanadium 5 oxide is for contact process, so it's sulfuric acid. 35. The diagram shows part of a polymer. Which diagram shows the monomer from which this polymer is made? So there is no alcohol, so we can just exclude it. And from the structure, we can see that it is an addition polymer. It's an addition polymer. And for addition polymer, we know that the monomers are alkenes. For addition polymers, the monomers are alkenes. Over here, the only alkene is this. We can also check it. If we see like, and for addition polymer, we at least need like 2 carbon monomer, and they should at least be 2 carbon. So if we consider this as a repeat unit, so we have this as a repeat unit, this is another repeat unit. So we just put double bond over here, and we remove these bonds, and this becomes the alkene. 1 carbon monomer is not there. At least 2 carbons should be there. So it's C. 36. Nylon and PET are polymers. Which statements about these polymers are correct? They are both condensation polymers. Yes, they are. They are not addition polymers, they are condensation polymers. This monomer could be a monomer for both polymers. And the complete combustion of both polymers gives 2 products only. Polymers cannot be combusted. It's one only. See. 37. Ethane is used as a fuel, which equation shows the complete combustion of ethane. So in complete combustion, we have carbon dioxide. It's not carbon mono, it's not carbon mono, it's not B, it's not D. Let's see the balancing now. There are 4 carbon, there are 4 carbon. There are 12 hydrogen and there are 12 hydrogen. There are 14 oxygen and there are 4 to the 8 oxygen, and 8 plus 6, 14 oxygen. So yes, A is correct. 38. The painkiller paracetamol is synthesized from 4-aminophenol. Chromatography is done on an impure sample of paracetamol. Results are shown. Diagram is not drawn to scale. S is impure sample and P is the pure sample. Sample of paracetamol is contaminated with 4-aminophenol only. What is the RF value of 4-aminophenol? So So out we know that S is the impure one, right? How do we know which of the two spots is for uh, 4-amino phenol? We can see that S has this spot and P also has this spot. So this spot is for the pure one, like it's for the is the substance that is also present in the pure one. So this one is the 4-amino phenol. This one. So we're going to calculate the RF value of this. RF value is the distance traveled by solute upon distance traveled by solvent. So we have 2.60, and for the solvent it's basically from here to here. That's 3.50. 2.60 upon 3.50. We have 0.743 and 3.7. C. 39. Equation for the reaction of aqueous calcium nitrate and sodium hydroxide is shown, which process is used to remove calcium hydroxide from the mixture. Calcium hydroxide is solid, as we can see, it is insoluble. So what can we use? Chromatography? No. Crystallization? No. Crystallization is for soluble compounds. Distillation is for liquids. Filtration is for insoluble compounds. 40, and the last question. The results of two tests on aqueous compound X are given. What is X? So these are some tests. So warm with aluminum foil and aqueous sodium hydroxide, ammonia is produced. This is basically the test for the nitrate anion. Second test is aqueous sodium hydroxide is added and there is a brown PPT. Brown PPT is given in iron 3 plus. If it's iron 2 plus, it's green. So it's basically iron 3 nitrate. It's A. So we're officially done with this paper. 0620 winter 23 QP 21. So thank you and see you in the next video.